Oh, hey, there we go. If I put you in live chat, do I see everything? Yeah, okay, just takes a second. Fantastic. Well, welcome, Ajay. It's just me and you so far. The internet bringing us together. I got the chat saved in the or stuck to all my different desktops, so I'm just going to start talking about packet captures, I guess. And right now, as I said, just me and you. If you have any questions, and pop them in the chat, and I'll do my best to answer them. Or if I can't answer them, I'll just lie, I guess. So what I've got right now is I've got two virtual machines up and running that are directly connected to one another. And so I've got a Kali instance running here, and then I've just got an Ubuntu instance running over here. And if we take a look at the interfaces, we've got 10.10.10.2/24. Oh, and I got another message that's probably from, oh yeah, that's from you. All right, I'm just going to ignore that because you're already in. All right, and over here on the Kali box, we've got 10.10.10.1, and it's also on the /24. So these two are directly connected. They're virtual machines. If this were a real-world scenario, these would be plugged into the same switch or the same VLAN. Basically, they're on the same layer 2 broadcast domain. And when we talk about packet captures, at least when I talk about packet captures, you know what? I just can't not check your message. Yeah, there they go. Okay. All right. So when I talk about packet captures, I really talk about them, I'd say about 90% of the time with different customers, with different clients, with people that'll listen basically, in terms of troubleshooting. They're good for doing network security, they're good for troubleshooting, they're good for pretty much anything that you can think of, anything that has that goes across the network basically. And it doesn't even have to be a network issue. So what I mean by that, so what I can do is, let's do nc-l-p1234. So what this does, NC, pardon me, is a program called Netcat. And what we're telling it to do is we're telling it to listen on port 1234. So if we open up another terminal, new tab, and we do netstat-nap grep list grep-v unix, you can see port 1234 for TCP is currently in a listen state. So what we can do is if we go over here and we telnet to 10.10.10.1 on port 1234, we get connected. We can type stuff in, hello, how are you, awesome, and then close the connection. And Netcat, if we go back to the other terminal here, you can see it just basically opens up a network port. It's kind of like Telnet, it goes back and forth. Now if we do the same thing again, then in our other tab, we do tcpdump VVES0XC100I ETH, what was it, ETH1? ETH1, yeah. 1 port 1234. So the syntax that I use, as you can see, I type this out really fast. It's because this is my go-to syntax. I use it all the time. So -NN means don't resolve host names and don't resolve service names. So without that, it might say alice.http. With -NN, it would say 1.2.3.4.80 as an example. -VVV is the maximum verbosity. -E gives us the link level headers. I don't know why that was so hard to say. That's like your MAC addresses. -S is the snap length. How much of the packet do we want to capture? So we set that, or I say we, but it's the royal we, but I set that to 0 so that it captures as much of the packet as there is. -X will print the hexadecimal on the left and the ASCII on the right. -C, this is probably the most important flag that you can set. This tells tcpdump to only capture a specific number of packets. In this case, we're only going to capture 100. We're not even going to actually use that much. And the reason that I say that this is one of the most important is because if you're SSH'd into a machine, let's say, or you're telnetted in, or you're logged in remotely, and you don't set your filters properly. So right now we're looking for 1, 2, 3, 4. But let's say we didn't have any filters on here, and you SSH'd in. If you did packet capture on the interface that you're SSH'd in on, the moment that you send one bit of information across that SSH tunnel, it's just going to start filling up the buffer. Now, it hasn't happened in a long time, but I've actually seen it where packet captures if done incorrectly, will actually fill up the memory buffer on the network interface card, and you'll just lock yourself out and the machine is toast. You have to go and hard reset it. So definitely put in the -C and then the 100 or however many packets you want to capture. Then we specify -I, which is the interface name, and then we put our filters together here. So these are BPFs, Berkeley Packet Filters, and they're standard across Wireshark, tcpdump, and a bunch of other excuse me, different utilities. So now that we've got this set up, we've got our packet capture listening, we have our netcat listening. What we're going to do is we're going to swing back over here, we're going to telnet in, and we're going to send whatever. We'll send something new. Let's say it's really cold where I am right now. We had 30 centimeters plus of snow today. It sucked. All right. As you can tell, I'm having a really good day. So first off, before we look at all that other fun stuff, you can see this got sent over the network. Let's take a look at our packet capture. What did we get? So the first packet that we get, so because we're dealing with TCP, we have to do the three-way handshake or the TCP handshake or whatever handshake you want to call it. So the first thing we get is our IP address, the source, and our source port. So again, without the -NN, if I had DNS resolution for 10.10.10.2 and service resolution for 44.486, then these would be names and not numbers. So we're going to come back to this 44.86 in a little bit. Then we have the destination of the packet. In this case, it's 10.10.10.1 on port 1234. The TCP flags that are set right now, it's just SYN, right? Because all we're doing is we're starting the TCP connection. We know that the three-way handshake is SYN, SYN-ACK, ACK. We have our sequence number here. The kind of fun thing about this, if you take a look, we're just going to remember the numbers 2033. We have the maximum segment size, that's TCP, whole bunch of other stuff, and not a lot of really good stuff happening here, right? Sorry, I did actually skip over a bunch of stuff. I jumped all the way to layer 4 when I should have really started at layer 2. So we've got our source MAC address up here, our destination MAC address here. We're using IPv4, the length of the packet, any sort of terms of service that are set. TTL, we'll talk about that again in a little bit as well. Don't fragment is set. Now in IPv4, you can actually fragment packets along the hop. In IPv6, they've gotten rid of that as a security measure. So then we get TCP as our protocol, which is IP protocol 6, and because I have no social life, things that I've memorized, ICMP is IP protocol 1, TCP is protocol 6, UDP is protocol 17, ESP is IP protocol 50, GRE is 40, oh no, I'm going to kill myself here, it's 41 or 47. Anyways, so we're dealing with TCP. So we've got our SYN packet, and that's all encompassed right here. Now the next packet that we expect back, and because there's no firewall between here, we get it right away, is a SYN-ACK packet. And a couple things to take a note of here. You'll see that the source MAC address is now the destination MAC address, because everything basically just got flipped around, right? So this packet goes out and this packet comes in. So our source IP and destination IPs, those have flipped around as well. And we have a SYN-ACK packet. When you're running TCP dump, the ACK flag is demonstrated by the little dot there. Now, we have another sequence number here, which we're kind of going to ignore right now, but we have our initial sequence number up here, sometimes called the ISN, because it's quicker than saying an initial sequence number. Excuse me. And our ACK packet is always the ISN plus 1. So you'll see that it goes from 2033 to 2034. Nothing super crazy there, but it's good to know. Then we finally get our ACK packet, closing off the three-way handshake, and we now start sequence 1, ACK 1. So now we're actually starting the conversation right after this. Now, excuse me, what's really cool about packet captures is any traffic that is not encrypted, you can read. So I'm sure you've already maybe taken a look already ahead there, but the first thing that I sent was, it's really cold where I am right now. It's actually gotten a little bit warmer, but it's still pretty damn cold. And if we take a look, you can see what it is that's been sent in plain text, right? Sequence 1 to 41, and then in the next packet, we ACK 41. So TCP is error checking and error correcting. So if this didn't say ACK 41, we would send additional data. right? So if you take a look at the next one where I said we had 30 centimeters plus of snow today, which we did and it sucked, you'll see the sequence starts at 41. So again, if we only act to 32, we would start our sequence at 32 and we would send part of the previous message in the next message. And every time TCP sends a packet, so here we have a push ACK, we have to acknowledge it as well, right? So if we don't get an acknowledgement, we're actually going to send a TCP retransmission. We're going to send the same packet previously, we're going to send it again. Right, so down here we have our ACK, right? So we sent up to 71. You can see we ACKed 71. And then I said it sucked. And let me tell you, shoveling 30 centimeters of snow all day, it sucked. And we 71 to 83, ACK 83. Now, when we close off a TCP connection, it's a graceful close as well. So there is actually a closing handshake. So we've got fin ACK, so we're telling it, by the way, we're done, right? So this is our client, where we sent the control square bracket. It sends a fin packet. It acknowledges the fin packet and sends its own fin packet, and then it acts as well. Now, I've been doing this for longer than I'd like to admit, and I just learned about something a couple years ago, which kind of blew my mind. So we have a SYN packet up here, and then we have a SYN ACK packet here. Why do we have two SYN packets, right? I always kind of wondered that. And the reason is, right, so we've got our ISN here at 2033, and we have an ACK here. This SYN packet, right, with this specific ISN, is tied just to this ACK flag, not the entire packet. We have another sequence number here, which is tied to this SYN flag. SYN flag here. So TCP is actually two connections in one. So an entire TCP flow is a connection from the client to the server, client to the server, and then another back connection from the server to the client. So that's why we have a three-way handshake with two SYN flags, which I think is really interesting. There's another protocol that's kind of, I don't want to say it's gaining traction, but it's relatively new. It's called SCTP, and it still has things like error checking like TCP has. But what's really interesting about SCTP is you can take multiple sources and have one stream of data with different parts of the stream coming from different sources going to one destination. And then the receiver takes all those pieces, bundles them together, and puts the payload together. I think that's, I haven't played around with it a whole lot, but I think that's kind of cool. And it has flags in it as well, like TCP has, but it's a little bit different. The flags, I don't even know what they are off the top of my head. It's basically start, like transmission start, but anyway, I'm kind of getting off topic here. So, kind of dialing things back in and keeping myself reined in, I did talk about doing this for troubleshooting, not just for network-related issues. So right now, if we run our netstat command, no, that wasn't it. Netstat-nap grep list grep v unix. So right now, the Kali machine has no ports in a listen state. So now if I go over here and I try to do this, I get connection refused, which is what we expect. Now, I don't want to say all the time, but quite often when I'm dealing with customers that are not in networks specifically. So if I'm dealing with a customer that's a large organization, and let's say they have a server team or a web server team or an SSH team or whatever you want to say, but they're people that run servers, they don't run actual networks. A lot of the times you'll see people say, oh, it can't be my server is configured correctly, blah, 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 blah. And packet captures will always give you proof. They will prove that it's a network problem or that it's not a network problem. And you do packet captures along the way. And as long as you do them properly and interpret them properly, you're always going to find out where your problem is. And more often than not, they'll help you determine what the problem is, not just where the problem is. So we're not starting up the netcat session again, but we are going to run another packet capture, the exact same one that we ran before. We try this, we get connection refused, which is what we expect. And we see our SYN packet, which is, again, what we expect. And we immediately see a reset packet. So when we talk about closing connections, I talked about the fin with the graceful close. There's a reset, which is an ungraceful close, if I could talk properly tonight. And this just basically tells the client, there's nothing here for you, I'm stopping the connection right now. You can send resets in the middle of a TCP stream, and the TCP stream will not close gracefully. But if the port is closed and there's no firewall on the host, you're going to get a reset packet. So a lot of times I see customers that have web servers or any kind of server that you can imagine, and people do they try to pass the buck, right? They try to push it off and say it's not my problem, it's not my problem. And I can say that when as a network security engineer, when I work in pro services, being able to take the problem yourself and prove that either it is a firewall or a network problem or it's not will really make you stand out, and it makes you seem like a hero. Because in this situation here, sorry, I was pointing at my screen, but you can't see it. In this situation here, if the port is closed, then nobody's actually going to be able to get to the connection, right? So you might have somebody on the web server side say, my web server is configured properly, it can't be my web server, right? If you do your packet captures on all the different access switches, on the VLANs, on the client itself sending the packet out, and you do it hop by hop, and the last place that you need to investigate is the server, then put Wireshark on there if it's a Windows machine, and if it's a Unix box, then just fire up tcpdump. If it's a Solaris box, put Snoop on there. But do the packet capture there as well. And a lot of times you can actually point to the customer and say, look, we're sending you a SYN packet and you're sending us a reset, right? Now, what that does is it gives you 100% conclusive proof that right now the issue is not with the network. It's not with the firewall. We're not missing routes on the ASR or whatever it happens to be. And with this information, you can go to the customer or the client. You can say, look, we send a SYN packet, you send a reset. Can you run a netstat on your server and make sure the port that we're trying to connect to is currently in a listen state, right? You'd run something like that, and you will seem like an absolute hero. It's absolutely fantastic. So one of the things I wanted to talk about was the TTL, right? So this is interesting. So what I'm going to do is I'm going to network connect that second adapter, which should be in a NAT state. So give it a sec here. It is a classic use case scenario, absolutely, man. And as much as I do pen testing and red team stuff, as much as I do NetSec and InfoSec, a lot of the times this can be used for, I don't want to say proving people wrong, but it's really proving people wrong, but it's to solve a problem, right? It's a fantastic tool to have for pretty much any situation or scenario. I'm gonna have to go get some more coffee here in a sec. So now if I do netstat -nr, all right, ping for, whoop. All right, so now this guy's out on the internet, and what we are gonna do, welcome Jason White. Yeah, absolutely, man. You definitely have to prove your innocence. You have to say that it is the firewall or it's not the firewall, or yeah, I kind of figured prove our innocence. The thing is too, right, is if you have the ability to run a packet capture and you do it properly, I break everything down into twos. There are always two decision trees to make, and you do this along every hop, right? So you start with the client. Is the client even sending the packet, right? Maybe there's some goofy outbound firewall rule that blocks it, right? So, does the packet leave the client correctly? You've only got two answers, yes or no. If it doesn't leave, you know that your first point of investigation is going to be the client, right? If it does leave, then you take a look at the next hop, and what's the next hop going to be, right? If you're in a large organization, it's probably going to be an access layer switch. So you might want to do a span port on the VLAN, which could be a little bit dangerous, I'll admit, right? If you've got a giant VLAN that spans across 10 different access and distribution switches, that could get overloaded. But you do the packet capture on the switch if you're able to, right? And then you just do it one by one. And the question that you need to ask yourself each and every time is, does the packet arrive correctly? And if it does arrive, right, again, you've got two choices, yes or no, right? So if it leaves the client, but it doesn't arrive at the switch, odds are it's either a cabling issue or an actual like a GBIC issue or a transceiver issue or something wrong with the client itself, right? You're gonna find that out. So it needs to arrive, but it also needs to arrive correctly. Excuse me. And that's really key, right? If it arrives, but it arrives incorrectly, then something has changed the packet along the way, right? Maybe there's a NAT device in between. Maybe there's somebody doing QoS. Maybe terms of services got added onto the packet somehow inside the header. So once the packet arrives correctly, the next question is, does the packet leave correctly, right? And again, you've got two options. Yes, it leaves correctly, or no, it doesn't. And when I say, does it leave correctly, right? If you were talking about a firewall, if there's NAT involved, does the layer 3 header get rewritten to the proper address, right? If it's source NAT or destination NAT, right? Now that we're talking about layer 3, does it go at the correct interface, right? Maybe the problem is with the firewall. Maybe I was goofy and I had a route going out somewhere, or my BGP access lists aren't set up properly, right? So as you run your packet captures, it's only ever two options. Does it arrive correctly? Does it leave correctly? And wherever you get to the point where the answer is no, that's your first point of investigation. And a lot of the times I tell customers too that I'm dealing with, I'll say it's not the firewall right now. It could be the firewall later on, right? But right now, it's not the firewall, right? All we want to do is we want to get from point A to point B. We just want to send that one SYN packet. This is what I'm interested in. Now, because networks run at ridiculously fast speed, it's kind of hard to sit there and say, SYN, SYN-ACK, ACK. You're not going to sit there and run packet captures with a specific TCP flag, right? So, if I scroll back up here, right, this went blazingly fast. If we take a look, the time difference between the SYN packet and the ACK packet was within, let's see here, tenths, hundredths, thousandths, like 10 millionths of a second. Now, granted, they're on the same machine, they're connected in a VM, but, if you see the SYN packet show up and you don't see the SYN ACK, you kind of have a good idea that you've got one-way communication, right? There could be something in between. But at the same time, when you break it down, you need to kind of take a step back, take a deep breath. I've caught myself, not seeing the forest from the trees, and I get really anxious, and I'm like, holy shit, what's going on? But, as long as that SYN packet shows up, I'm looking for a SYN ACK. And that's really, as long as you break it down, as I said, I'll stop talking about this part. But as long as you break it down into those two questions, you're always going to figure out where the issues are, right? It could be the network, it might not be the network. And when you bring this to customers, when you say, and when I say customers, I mean, it could be people that are still in your organization. If you're a network admin, your customers are your users, right? So when the server guy says, Ajay, there's a problem with the firewall, it's not letting the web traffic through, right? You run your packet captures and you can say, look, I'm sending you a SYN packet, but you're not sending back that SYN ACK packet, right? This is concrete proof of what's happening on the wire, right? You could sit there and type all this garbage out to try and lie, but it's just easier to grab the bull by the horns. And as I said, you seem like a superhero, because what's going to happen is you can actually, if it is a problem with the firewall, you're going to know right away, because the packet's going to come in and it's not going to leave correctly, right? You can figure that out. So now that we actually have connection to the internet, what was I going to do here? So I'm going to start with a new screen. Now we're on ETH0, and let's do, let's see here, let's do port 53 or port 80. Fantastic. All right. So what I'm going to do is I'm going to make the most basic web connection out to the internet that I can. And it's to a site. Do I have e-links on here? No, I don't. All right. Firefox. Come on. I believe in you. There we go. ASDF.com. I love this page. One of the reasons that I like this page is it's very basic, and there's no TLS. There's no SSL, there's no encryption, no nothing. Right? Let's take a look at what we got. Oh, a whole bunch of stuff here, eh? Firefox tried to load a bunch of other stuff too. Fantastic. Holy shit, did it ever. Another good reason to set your packet count to a whatever you want to set it to. I set it to 100. If I didn't, there might be a ton more stuff going on here. All right. So we've got a DNS for detectportal.firefox.com. So this is our DNS request. As you can see, I talked about the layer 3 to layer 4 numbering, right? This is a DNS request. It's using UDP, which is IP protocol 17. Right? You can see it's an A request, and there's the domain. And again, because it's not encrypted, that's what we're looking at there, right? We're also doing a quad A lookup, which is the IPv6. I don't have IPv6 on these machines here. And then what do we get back, right? So we get back the CNAME and all the different canonical names that are tied to detectportal.firefox.com. All right, let's see if we can find ASDF. Oh, there's the detect portal. Actually, you know what? We don't even have to worry about ASDF. We got a plain HTTP request right here. Fantastic. So here we have our client going out to detectportal.firefox.com on port 80, right? So again, when you're using the -NN, the last dot are your ports, and we'll talk about source ports again in a little bit, right? So we've got our SYN, we've got our sequence number. One of the things, as I said, I want to talk about is the TTL. Now, this one I don't think is going to matter because we're in a VM environment. So we'll talk about it again, but maybe just in theory. So we've got our SYN, we got our SYN-ACK, we got our ACK. Now, the newer versions of tcpdump are fantastic because they will just tell you in plain text, oh, by the way, this is what we got, right? This is good, but I don't recommend getting too used to it, right? If you're on a checkpoint, for instance, checkpoint doesn't give you this degree of information. If you're on a Fortinet, it doesn't give you this degree of information. If you're on a Cisco, a ASA, it doesn't give you this degree of information, right? But again, everything that you see here is down here, right? So again, if it's not encrypted, you can read it. So if there are people sending emails in your organization, your SMTP server doesn't support TLS, you can read everybody's email. Yay, super fun. I'm sure that's a violation of many different policies, but it's, you know, just in theory, right? Okay, so here we go. Then we get the actual data, right? So it acknowledges what we asked for, and then the server sends to us, the client, 200 OK, text plain, blah, blah, blah. It gives us an E tag tagged on there. We know that we're going through or not through, but to an Amazon S3 bucket. This looks like an Amazon ID of some sort. I'm not a big Amazon guy. But again, anything that you see here, you can see down here, right? So when you're putting your packet captures together, you want to know what it is that you're looking for, right? So again, the BPFs that I used were port 53 or port 80, right? So you can tie that together, and we can make it even more specific, right? So we could say, let's just get rid of that, right? So we can open bracket that. We can say UDP and port 53 so that we don't get any TCP DNS lookups or any zone transfers, right? And then you can say, or, you know, host, I don't even know which one it is, right? But we can do, yeah, whatever. We'll just 1.2.3.4 and port 80 and TCP, for instance, right? So you can tie these together, and what we have here, we've got logic gates. So inside each of the bracketed systems, or the parentheses area, these are going to get combined so that it has to match UDP and port 53, or it can match these three criteria as well. And I've tied these all together with AND statements. So it has to be port or host 1234, it has to be port 80, and it has to be TCP. So you can get really complex with a lot of this stuff. But again, as goofy as it sounds, like, you know, the capturing limit is very important, because if you don't set that and you screw up your filters, then you're just going to end up with a ton of different crap up here that you don't care about. You might lock yourself out of the box. If it's older hardware, I would strongly recommend, again, setting your capture limit. So the TTL, I don't think I'm going to be able to, actually, you know what? Here, let's look at my desktop. Hey, 3 people, fantastic. So let's do one of those, and then we do tcpdump, and then vvv. Let's 0xc100 wlan0, and we're going to do ICMP. And then what we do is we create a new terminal, and then we do ping-c2 8.8.8.8. All right, exit out of that terminal, Control-C. Don't stay logged in as root. All right, so here the initial packet that goes out. So I'm pinging Google somewhere here. There we go. All right. So my TTL is 64. And oh, this is weird. You know what? I found myself something interesting, maybe even problematic on my network. The whole idea behind TTL, anyway, is the number of hops that a packet can take. It has absolutely is nothing to do with time. The actual acronym stands for time to live, but it actually is the number of hops along the way. So depending on the operating system, the TTL will start at a different number. So for most Unixes, it'll be 64. And what'll happen is every time a packet crosses a routing device, that TTL will decrement by 1. So if I had to go across 4 different hops to get to my destination to 8.8.8.8, the actual return TTL is going to be 60, right? So again, it has nothing to do with time. I think it's a bit of a misnomer to have the acronym as TTL, but you know, 30, 40, however long it was when the internet got created, or at least IP got created, they came up with the acronym for TTL. And this is really handy to have a good understanding of, because now you'll be able to understand, just by looking at the layer 3 headers here, how many hops the packets have gone, right? So if you expect, let's say you're a big router guy and you've got all these different BGP confederations set up, and you expect that, you know, going out ISP1 is going to take 10 hops to get to the customer, and going out ISP2 is going to take 20 hops, as an example. You can take a look at the raw packet data and say, you know what, we're getting 15 hops out of ISP1 instead of the 10 that we expect. There might be something weird happening in the confederation upstream that we need to take a look at. Now, it's probably not going to be the best indicator that you're going to be sitting there looking at packets all day long, but if you notice that you're having BGP issues, you know, as you run your packet captures looking for BGP, and you notice that your TTLs are wrong, then that'll give you a good indicator as to what happens, or what could be happening, I should say. We don't want to jump to conclusions. What could be happening upstream. When we talk about TTL as well, this is a really good segue. You know, people talk about traceroute, right? So, you know, I'm going to do a traceroute over to Google and see how many hops it takes or whatever. The way that traceroute works is a combination of UDP and ICMP. So when the initial packet gets sent out by the Windows machine, the Unix machine, the Mac machine, whatever machine, it sends it out with a TTL of 0. And what happens is the packet's going to reach a firewall or a routing device. I keep saying firewall because I'm a security guy, but it's going to reach a routing device. That routing device is going to take the packet and say, I need to forward this to another gateway because destination 8.8.8.8 is not on any of my connected interfaces. So it needs to decrement the TTL by 1, but it's not allowed because the TTL is 0. So that routing device has to send a message back to the sender, and it sends back an ICMP error message saying TTL expired in transit. Now remember, right now we're just talking about traceroute. So when that ICMP message comes back to the client, to the initial sender, that sender records that as the first hop, and then it'll send the packet out again. But this time it sets the TTL to 1. So the first routing device is allowed to forward it, at which point it decrements the TTL. The next routing device receives it, tries to do the same thing, can't do it, sends back the ICMP error message, and that's how you get all the different hops that you normally see inside of traceroute. Interesting little fact is, and it's been a while since I worked on ASAs, but the older ASAs, and it might still hold true for the newer ones, is they would actually decrement the TTL on the way in and then re-increment the TTL on the way out to make sure that the ASAs were invisible for anybody trying to do a traceroute. So you would actually not even know that you were going across an ASA device if you had one. Excuse me, sorry, I didn't mean to cough in everybody's ears. Apparently I'm just dying. It's fine. So that's how TTL and traceroute kind of play in together. which is really interesting because, you know, you talk to different people out there and they're like, oh, you know, just run a trace route and off it goes. But the port has to be open. So one of the things that I recommend, and I don't know if I have it on the VM, so I'll just grab it here. Let's go back to root. There we go. TCP trace route. You can get this for at least for Ubuntu in the just by doing apt install. Windows has another one called trace TCP, but the whole idea is that instead of using UDP, it uses TCP, because a lot of the times the UDP port will be blocked by a firewall that goes outbound. So even if you try to do a trace route, it's going to get stopped at the border device. And then it takes the same kind of switches, and then so we say -n because I don't want to resolve host names, -q1. I only want to do one query per hop. I don't want to query it 3 times, which is the default. -m is the maximum number of hops, so I only want to do a total of 15 hops. My destination is google.ca, and I'm doing this on port 443. And when I run that, you can see we get the actual packets going here, right? And you know what? Let's see if we can do a trace route or a TCP dump. Super duper secret password. Port 443 and host. Let's try that again. All right. So I don't know if you guys are going to be able to see this, and hopefully that weirdness isn't happening on my network. Oh, here we go. So as I mentioned, right, you know what I might do? I'm going to grab this and make it a little bit easier for you guys to read. Let's just grab all of that. Stick you in a text editor. Come on. There we go. Hopefully that'll be a little bit easier to read going over YouTube in a transparent terminal. All right. So here's our first packet that we're sending, right? You can see we've got our SYN flag here, but take a look that we have the TTL is set to 1. And then our next packet, the TTL is set to 2. Then we have 3, 4, 5, 6, 7, oh, and then 122, right? So 122, right? So if our default TTL on this is, let's see, we jump up 8 hops, 130, 132, that's kind of weird, doesn't seem right. Anyways, 128 probably. Yeah, 128, sorry. The TTL on my host OS is going to be 128. And we figure that out because here's our SYN and here's our SYNAC, right? So we are 7 hops away from Google, right? And then we just send a reset packet. And as we talked about earlier on in the stream, reset is we're done, we're closing the connection, right? So we don't even complete the TCP 3-way handshake, right? We do the SYN, we do the SYNAC, we get those 2 packets here, and then we get the reset that the client sends. Way back in the day, and I'm probably going to date myself here, this was a really fantastic way of evading IPS systems to do recon, and you couldn't do enumeration, but you could do recon on this. And this is basically it's considered a half-open TCP attack. SYN flooding, those kind of denial of service attacks, they have the same thing, right? And what's interesting is instead of sending a reset for a SYN flood, it'll just do SYN packets, and then it actually dumps the connection out of the client. You really can't do that nowadays. As I said, I'm kind of dating myself. But so getting back on track again here, we've got our TTL, and that's how traceroute works. It just keeps incrementing the TTL until such time as it gets a response. All right, let's not stay logged in as root. Let's keep saying that over and over because it's never good. So again, that program is called TCP traceroute. The Windows version is called trace TCP. If you're on Windows, I think you need the WinPCap libraries to get that going. And yeah, there's all sorts of different things. It's getting a little bit late where I am. I still got a bunch of other stuff I got to do around the house. I'm going to give it about 2 or 3 more minutes. I'm going to wrap up here, guys. So if you have any questions right now, by all means, drop them in the chat. And as we kind of close off here, I'm going to kind of whore myself out a little bit. So, you know, I'm guessing that you guys follow me on Twitter, and if you don't, I definitely appreciate the follow. Twitter.com/graverose, grave_rose, I should say. Let's go over to my page. Yay, super duper popular. Now, the one thing that I also kind of want to show here is tcpdump101.com. I've been working on this for quite a number of years now, and this is the production page right now, and I'm really kind of working a lot on the development page here. So the whole idea behind this is being able to put packet captures together on different devices. And I didn't write this one that I'm going to show you here, but it was definitely the inspiration. There's somebody that created regex101.com, and this little tool is fantastic if you ever do any kind of programming, or if you're writing, let's say, regex for log filters on whatever, right? If you've got well, I was going to say an elk stack, but that's a little bit different. But the whole idea behind regex 101 is you put your stuff in here, and you do your expressions up here, and it'll tell you what matches. I highly recommend regex101.com. But as I said, there was nothing that I found that helped people build PCaps online. So I started off with a very basic one that did it for tcpdump, and then I eventually got it for FortiGate. I got Checkpoint, all two different packet captures that Checkpoint has. I've got flow debugs for the FortiGates. I've got kernel debugs for Checkpoints. I've got an ASA 5506 sitting beside me right now, so I really want to get the Cisco stuff done as well. And if you've never seen this before, I'll do the tcpdump one. The whole idea is that it's a web page. It's all self-contained. It's HTML, CSS, and JavaScript, so you can download this yourself if you don't want to go to my site. If you want to use it offline, if you're on an air-gapped network. And this is the dev one, kind of showing off here because it's got some more features. But the whole idea is that you just fill in all the different options that you want, right? So I don't want to resolve host names. Thank you, Ajay. I appreciate that. I'm always looking for feedback. So, if you've got any feedback, positive or negative, I like this, I don't like that, by all means, I really, I haven't made any money on this. I've gotten one $15 donation in the 3.5 years that this has been running. Right now, I want feedback. Money's good, but feedback is really what I want. But yeah, so you just put together whatever it is that you want here, right? Maximum verbosity, payload, set your snap length, do whatever. You go back to the top, you can hide all this, right? If you want to output to a file, you can do that. And then all your filters are on the right hand side. Now the production one, all the different filters are added below. Thanks very much, Jason. I appreciate that. I'm glad that you use it, and I'm glad you find it handy. Right now, as I said, in terms of the feedback, it's really just through word of mouth. I get a couple people every now and then that say, hey, I like this. I don't want to sound egotistic or tooting my own horn, but over at the Checkpoint Checkmates forums, I don't know if you guys use Checkpoint or not, but I got a lot of really good feedback from those people there, and it's a lot of the things that they suggested I've implemented in the dev build. And one of the key things that I'm really kind of proud of, right? I'm just putting garbage in here. But the production one, every time you add a new filter, it always adds it below, right? In the dev one, right? So let's say we're looking for ARP, right? I'm just picking random things here. We can add a filter below, or we can add a filter above, right? And now the ARP one, which is now down below, right? You have your operands, and let's say, I didn't really want this. When you delete that one, it gets rid of the operand up top, right? If you wanted to, you don't have to click on the little copy button anymore. You can just click on the bar, and it copies it to your clipboard for you, right? So you can now add filters above and below other filters. In the dev version, I've put contextual help over everything. I've got, little question marks that, will tell you about every single option, what it does. Right, even on the. Oh, excellent! Thank you, Jason. Are you in TAC in Ottawa by chance? I realize there's a delay, so I'm kind of sitting here with with not saying anything. But as I wait for your reply, right? So. We can filter on specific IP addresses, and we've got, oh, you're not, okay. Oh, excellent, thanks, Ajay. Oh, you're a customer of Checkpoints, fantastic. Yeah, I used to work at Nokia way back in the day before Checkpoint bought them out. I was there from 2003 to 2006, and it was a really good learning experience. I learned a lot, and we still do a lot of Checkpoint work where I work as well too. So we do a lot of Fortinet, not as much Cisco, a lot of Aruba, and those are different things that I want to add on here as well too, right? So as I said, feedback is great. The other thing that I'm doing now, so let's pick Checkpoint, right? So FW Monitor, great utility, but it's a real pain in the ass to do these different filters. And the reason that it's a real pain is because they don't support BPFs. They don't support the standard Berkeley packet filters. You can't just type, host 1.2.3.4 or whatever, right? So, excuse me. Under the debugging display, I mean, you can specify a specific VSX instance. You can output it to a file, which a lot of the times TAC is going to ask you to do, right? So you do, FW monitor.out, right? I want maximum debugging. Again, I want the maximum level of snap length. And then again, all the different filters that you put in here, right? So if we pick specific ports, right, source or destination, we pick port, 123. It does the syntax for you up top, right? And then if we add a filter below, and I'm looking for a specific host, and I want to say and we go here and we say, 1.2.3.4, it does all this for you, right? And if you're looking at a specific subnet, right, so a specific network, we do, 10.20.30.0/24. But because FW Monitor is kind of weird, it doesn't use the slash, right? I automatically change that from a slash to a comma, and it's all there for you. Right, same thing now if you've never played around with it, the PCap is a new utility that just came out in R80.10, I think it's available. And it supports BPFs, which is fantastic. You've got your different capture options. It's a little bit different for the syntax. It's different than tcpdump. So you've got your data network transport layer if you want to make that with additional verbosity. Again, set your snap length, your inbound, your packet capture count. And then the other thing I've got there as well too, are the kernel debugs, right? So you can specify, maximum kernel debugs, set your timestamp in microseconds, set it to, kdebug.out. And then you can change all your different modules as well too, right? So if you pick the KISSFlow module, the defaults are already selected. So error and warning for the KISSFlow module are the defaults. But if you need to change those, if TAC says, you're debugging a firewall issue and they want IPv6 turned on, you just click on this. And I know it looks ugly as all hell, but this actually is a valid command, right? So it turns on error warning, which are the defaults, which are already turned on, but it also turns on IPv6. And as I said, I know this looks ugly, but it turns off all the others, even though technically they're not on already. So that's the Checkpoint one for Fortinet. They support BPFs, which is really nice. As I said, I do a lot of Fortinet work as well. So, you can specify the interface to capture on, port 1, maximum debug, want to capture 100 packets, absolute timestamps, and then, do your layer 2 address for source or destination or whatever it is, right? And away you go. You just click on that, boom, copy to the clipboard. The other thing that I'm adding in the dev version, and this is going to be a constantly growing thing, command line tools for different platforms. So right now, just as a bit of a placeholder here, I've got interface configuration. It doesn't work for anything except for the Linux, and you can say, show ETH0, generate the command, and it will automatically put the command up there for you. What I've got now as well is you can actually add 1.2.3.4, and if you're in Linux, right, it's got a little thing there that says you have to use a slash notation, 24, generate the command, boom, there you go. Same thing for IPv6, boom. Obviously that's not a real IPv6 address, but you get the idea. So this is the dev version that I'm working on. Nothing else really kind of works right now. I've just got little placeholders and things like that. I've got a subreddit. If you're looking to give feedback, head over there. Eventually I'm going to have an RSS feed once I switch over from dev to prod with this new version as well. And that's pretty much it. So, it's slowly but surely coming along. I do it all myself in my spare time. I use a text editor to put it all together. And you know, as I said, I don't want to brag too much, but I'm really proud of it, and I'm just glad that it helps people out. Oh, son of a gun, AJ. Been working with Fortinet for about 12 years now, and I had no idea. Guess what? If that's going to go in there then. So yeah. So I guess, as I said, it's about 5 past 11 here. I still got a bunch of stuff I got to do around the house, and you know, real life jazz, and get off the internet. You know, if you guys have any questions, let me know. You know, drop me a line on Twitter. Head over to the subreddit and shoot me a message. Mr. Hawkson, what's going on, brother? Man, we got to do coffee soon. The Wireshark filters, so that's a little bit different. So Wireshark will do BPFs to start with, right? So you can actually use tcpdump on Wireshark, and you know what we can do is applications, Firefox. So Wireshark has BPFs and it also has filters, and those are two kind of different things here, right? So let's see here. Let's fire up Wireshark at the same time. Always down for coffees, brother. Absolutely, man. Well, I am done at that place that I was at that one time. It was 2.5 years, so I've definitely got time for coffees now. Here, let's just do this. Excuse me. All right, and we go here. Oh, yeah, whatever. All right, so we can do host www.google.ca, right? So this is a standard BPF, right? A Berkeley packet filter that you would get from tcpdump, right? So if we, I want that on ETH0, and let's go, right? And then we go over here. There we go. And then we stop that. So when you do your capture, Wireshark supports BPFs. When you do your filters, Wireshark does not support BPFs. It's a real pain in the ass because you got to learn both, right? You got to know the BPFs to get it started, and then you got to know your filters afterwards, right? So you would have to do something like ip.addr equals 1.2.3.4 or whatever it happens to be, right? You know, you could say tcp.port, you know, equals 443, which is going to give us the same exact thing, right? So again, with Wireshark, the BPFs work at the start when you do the capture, but the filters are completely different, and those do not support BPFs. So yeah, guys, thanks for showing up. You know, I feel like an internet superstar here with 3 people watching. It's fantastic. Hopefully I'll be able to do another one of these again sometime in the near future. I gotta, you know, schedule it around real life and work and everything. But I want to thank you guys for jumping on here. Ajay, thanks for helping get the. Oh, yeah. So as soon as I get the ASA stuff done, I would like to. I'm gonna move from dev to prod, and I'd like to start working on the Wireshark filters. That's a good point there, Tony. But if you take a look, right? Yeah, whatever. I don't care. Let's just capture a bunch of crap, right? I don't know if it'll still work, right? Yeah. Right. If you take a look at the different filters that there are. Oh, that's not what I want. No, expression. There we go. Wireshark has just a few filters. Now, thanks, Ajay. So yeah, like, I mean, like, we're not going to have, you know, like Boardwalk or anything like that, right? I'm not planning on supporting Bluetooth filters or, you know, like whatever the hell all this jazz is. But I would like to put in some basic network filters that you can use in Wireshark as well. You know, it's definitely kind of on the roadmap. Have a good day at work, man. I know nobody likes hearing that, but hopefully it's good for you. Yeah, I would definitely like to get filters supported in there at some point. So first thing I got to do is I got to finish off that ASA, and once that's done, then yeah, I'll work on the Wireshark stuff for sure. So again, guys, thanks a lot. I appreciate it. Hawkman, I'm gonna give you a call, and then probably next week sometime we'll grab some Joe. Ajay, Jason, everybody, thanks for showing up, and hopefully we'll be able to do this again sometime soon.